Welcome to This Explainer, where we dive deep into mastering the Cambridge 9618 hexadecimal practical applications. But listen, whether you're tackling syllabus codes 0417, 0478, 0983, 0984, 2210, or sitting for the advanced 9618 AS and A-level papers, the fundamental strategy we're breaking down today is going to completely change how you approach your exams. We're talking about making your mark. Think of it like being a street artist. You need to apply bold strokes of structured, analytical creativity to stand out from the crowd. Today, we are taking you from simply memorizing base 16 facts to actually securing every single possible analytical method mark on your paper. We're going to blend the raw data and logic of computer science with the exact structured framework that Cambridge examiners are actively hunting for. It's time to stop leaving marks on the table and start showing the examiners exactly what they want to see. 15%. Let that sink in for a moment. This single topic right here, hexadecimal practical applications and uses, accounts for a massive 15% of your total paper 2 marks. That is absolutely critical. We're not just talking about a passing multiple choice question. That 15% is literally the difference between an A and a C, or pushing from an A to that elusive A star. Mastering this specific cognitive domain is the absolute key to your exam success. If you've ever sat in an exam hall and felt like those multi-step calculations involving memory dumps or decoding MAC addresses just leave you completely lost in the weeds, or maybe you felt the frustration of losing method marks even when you managed to guess or work out the final answer, well, this is the exact metric you need to be focusing on. We have to move beyond just knowing what hexadecimal is and start mastering how to strategically apply it. So, here is our structured roadmap for today's explainer. We'll start with the challenge, move into the core strategy, break down the technical methodology, look at a real transformation of a student's answer, jump into an interactive workshop, and wrap up with the final system and crucial examiner warnings. Let's get straight into it. Section 1, the challenge. We really need to look at the most common ways students end up failing this section despite putting in hours of revision. Consider 2 typical students. We'll call them Alex and Sam. Now, when they're faced with a classic Cambridge question, say, evaluate the use of hexadecimal in a MAC address, their approaches perfectly illustrate the 2 biggest traps. Alex provides a classic case of superficial breadth. Alex is the kind of student who writes down absolutely everything they have ever memorized about base 16. They overload their answer with raw, disjointed computer science facts, talking about nibbles and 16 different characters, but they provide absolutely zero analysis or context regarding the MAC address itself. Then you have Sam. Sam rushes the problem. Sam is great at math, calculates the hex value perfectly, gets the binary conversion right, but completely misses the actual command word requirements. If the prompt explicitly says evaluate, Sam merely describes. Both of these students end up missing the true procedural requirements of the syllabus because they fail to link the hexadecimal mechanics, like why a MAC address uses base 16 for human readability or to condense binary strings, directly to the underlying system structure. They aren't decoding the command words. Section 2, the core strategy. To break out of this trap and start consistently scoring top marks, we need to understand exactly what the Cambridge examiners are targeting with these multi-step calculations. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so notice how application and analysis take up the absolute lion's share of your assessment domains. The theoretical architecture of this exam rests on precise definitions, yes, but more importantly, it rests on causal relationships. Why are we using hexadecimal for IPv6 addresses instead of binary? It's all about integration with other syllabus areas. The principal examiner reports explicitly state that candidates who reference cross-topic connections, like explaining exactly how a hex color code maps to an exact 8-bit register, achieve significantly higher marks than those relying on simple rote memorization. This is where you need to implement the Peel framework. Point, evidence, explanation, link. You make your point about hex, provide the technical evidence, explain the mechanism, and link it back to the specific scenario. You need to show the examiner you understand why the computer architecture requires this data structure, not just how to do the math. Section 3, the technical methodology. The crucial point here is how we tackle these algorithmic problems using a strict, unyielding, step-by-step procedural framework. By following this deconstruct, solve, evaluate method step by step, you capture those crucial method marks. Step 1, deconstruct the prompt to extract the exact data you need. Are you working with an IPv6 address, an error code, or a simple memory dump? Step 2, select your analytical framework. Step 3, break the problem down into completely logical, algorithmic steps. Step 4,
Execute systematically with perfectly clear notation. And step 5, evaluate and justify your final answer for reasonableness. If you train yourself to follow this exact methodology every single time, then even if your final mathematical conversion from binary to hex happens to have a slight calculation error, you will still pick up the vast majority of the method marks because the examiner can clearly follow your structured logic.
Section 4, the transformation. Let's see exactly how this methodology builds a top-scoring answer by replacing weak, generic statements with highly specific, context-driven solutions.
Think about a typical answer. A generic answer simply suggests, use a loop to check the hex value. Well, that might get you a single, lonely knowledge mark. But a top-scoring candidate, someone using our computer science success blueprint, deconstructs the specific scenario entirely. They don't just say check the value. They consider checking for boundary conditions. What happens when the system hits the maximum FF limit for an RGB color code? Or what happens when the processor encounters an exact 00 for an empty memory register? A top-tier response demonstrates true evaluative thinking by explicitly linking these edge cases to the given system, showing the examiner exactly how the algorithm processes those specific hexadecimal extremes. That is exactly how you turn a generic, forgettable statement into a high-scoring analytical masterclass. As the Cambridge syllabus guidelines explicitly state, top-performing students exhibit connected, conceptual understanding, transferable to unfamiliar contexts. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. You absolutely need these transferable skills to survive the unique scenarios examiners love to throw at you. It is never just about knowing base 16. It is about confidently applying that knowledge whether the question asks about assembly language operation codes, ASCII character sets, or identifying a rogue error in a massive network routing table.
Section 5, the interactive workshop. Let's put this into practice right now by extracting data from a complex data structure and finding the flaw in a sample problem. Challenge 1, the data scan. I want you to quickly scan these 3 distinct hexadecimal values, 1A, FF, and 2B. The core challenge here is extracting the trend from their binary representations and mapping them to their contextual applications. Give yourself a mental 60-second timer. Notice how 1A, acting as a memory address, requires a completely different processing approach than FF. FF represents a color code maximizing that 8-bit register with a solid string of ones. Your data interpretation skills here are absolutely critical. To draw evidence-based conclusions, you must look at that binary string of ones and immediately recognize the boundary condition it represents in a graphics rendering algorithm. Now, run your analysis through this algorithmic thinking checklist. This is where we do some mental speed writing and flaw finding. Begin with a step-by-step decomposition of the hex value. Then, justify your data structure selection. Why represent this specific MAC address in hexadecimal rather than binary? Is it for human readability, or is it to reduce screen space in a network diagnostic tool? Ensure your code implementation is efficient. And finally, rigorous testing. You must explicitly state how you would test the code against edge cases. If you draft a paragraph and you don't mention testing the system's response to invalid hex inputs or boundary limits, you are leaving massive marks on the table. Section 6, the final system and examiner warnings. We are now at the most critical part of this explainer, the inside track straight from the principal examiner reports on why students lose marks. Examiners consistently note 3 major mistakes year after year. These are the traps you must avoid using our 3 rules for top marks: command word decoding, Peel framework application, and a strict time management matrix. Warning number 1, using the wrong conversion formula or algorithm for the context. You might write a beautifully structured explanation, but if it doesn't fit the scenario, it scores a hard 0. Warning number 2, forgetting boundary conditions in edge cases. Candidates constantly lose marks by ignoring what happens at the absolute limits of a hexadecimal register. And warning number 3, perhaps the most fatal of them all, providing generic answers. If your answer could apply to any question about hexadecimal on any past paper from the last 10 years, it is way too generic. And this brings us to the ultimate examiner alert. The classic mistake is providing generic answers not specific to the question context. Whether you are decoding command words or evaluating a complex architecture, you must always link every single analytical point directly to the given scenario. For instance, if the exam prompt is about an automated greenhouse using hexadecimal error codes,
Your answer better explicitly mention the greenhouse environment, the specific temperature or humidity sensors, and exactly how those hex codes trigger physical hardware responses. That contextual link, that final L in your Peel paragraph, is the absolute guarantee for top marks.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let any other exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.